Hello, everybody. Welcome to Introduction to, I'll just skip through and say EKS, because that's a lot of words in between otherwise. I'm the GM for EKS. I'm the GM for Open Source Container Services at AWS. And although the talk is titled Intro to EKS, I think we will do, hopefully dig a bit deeper than that. One of the ways that we're going to dig deeper than that is we're going to practice good customer obsession in the classic Amazon way, and I'm going to spend as little time up here talking about stuff as possible and bring one of our customers up to talk about what they're doing, which will be much more interesting than what I will say. But I am interested in making sure that he has a little bit of baseline for the room so that you can get the maximum value out of his talk. So I'm Bob Wise. I've been working on Kubernetes since before the 1.0 time frame, which in Kubernetes years is a lot of years. I am presently involved in the Kubernetes project to this day. I co-chair a couple of the SIGs. The oldest and first SIG in Kubernetes was the Scalability SIG, working on how do you build really, really big clusters. But naturally, I've been at Amazon since the beginning of the year, and we're obviously deeply involved in SIG AWS. And if you want to contact me, I'm in Kubernetes Slack, I'm in all the Kubernetes community meetings, so if you want to find me in the open source world, I'm super easy to find there. Okay, so here's my audience baselining questions. Well, I'll do an easy one first, then I'll do one that's a little bit more inside baseball, perhaps. So who has some experience in the room with Kubernetes? You've built a pod, deployed something. Oh, don't be shy. All right. Maybe the room is not quite experienced enough for this, but I'll do it anyway. So I give you three choices and we'll vote. So do you say kubectl, kubectl, or what is he talking about? All right, so kubectl, who's the kubectls? All right, kubectl. That's about, don't know what I'm talking about. You will, not by the end of this talk, but eventually you will. All right, so moving on. EKS, we launched it fairly recently. Why did we launch it? Well, here's one of the main reasons. We practice customer obsession, and a couple of things happened. One is that it started to become obvious that a lot of people were running Kubernetes on AWS. This is the stats from the CNCF. And we were hearing from our customers, run Kubernetes for me. This is great. We love using it, but it is a little tricky to run, especially in production. So we love using it. Please take away the pain. That is not the only thing our customers were telling us. They were giving us very direct guidance in a couple of areas. These are all kind of related. Different ways to say the same thing, right? Make sure it's upstream. Please don't fork. Make sure it's compatible. These are all very strongly related things. And so that became these became kind of how we thought about what EKS should be, which is run Kubernetes, run an upstream version of Kubernetes without forking, keep it standard, and take all that pain away for us. So I said we launched very recently. And we had a lot of customers who are adopting EKS. So I love the slide. There's a lot of customers there. You see there's a little ghost slide, a little ghost icon down there in the corner. So that's the Snap icon. So we're going to hear from Snap here in a little bit. One of the key questions, well, what do people really mean when they say make it compatible? What they're really asking is, will my thing, this other thing, this thing that somebody else has, well, it works on Kubernetes. Is it going to work on EKS? And the answer is yes. And one of the ways to do that, one of the ways for us to ensure that we do that is not only to be running the upstream code and to be involved in the upstream project, but to go through the formal conformance program. And so we are certified Kubernetes, and we will continue to be. One of the great impacts of making sure that we can run anything on EKS is it has made it a really awesome partner experience. So we have worked with a ton of partners, an expanding group of partners, These are all companies that have made a bet on Kubernetes, and it's easy for them to also support EKS. So again, this is just telling the story not only of the great partner support, but our commitment to that standard upstream experience. So again, EKS. This is enterprise-grade, production-grade system, upstream, seamless integrations, not just with partners in ecosystem, but with the rest of the products inside AWS. Our goal here is to have a platform that is performant, highly performant, easy to manage, secure, stable, and removes all that undifferentiated lifting from our customers. And finally, we do actively contribute to the Kubernetes project. So a little deeper dive here. This is how we deploy and run Kubernetes in EKS. So the Kubernetes project supports a lot of different kinds of configurations. This is one of the reasons why it's, let's say, a little bit of a high bar to figure out how to run Kubernetes on your own. You can certainly get there, but there's a lot of different ways to configure and operate a Kubernetes cluster on your own. This represents one of the ways to do it. This is the one that we prefer for a bunch of reasons, and that is that there is a controller layer, and then there is a database layer. When you have the controller layer and the database layer, then you also have the actual workers. So what you see at the top is the controller layer run in a multi-zone, reliable fashion, and then workers, the nodes in Kubernetes, you bring those and assign them as you like. What you see here in this diagram would be, well, the top part is how we run the service. The bottom part is up to you, but we would consider this to be best practice. You would run some nodes in each one of the availability zones in a region. So this represents a regional deployment split across multiple AZs. Within the control plane piece, that top part that we manage on your behalf, there is a split between the database layer and the controller layer. So we are running a pretty large number of instances and managing these for you in a secure way. So again, if you were to build a bigger, more secure, more performant Kubernetes control plane on your own, you might well end up with something like this. It's more likely you might just say, oh, it's easy if I just set it up on one node and live with the consequences. But for us, we can, if you work with EKS, you get a much better experience. So this is kind of another view here. Well, see, I do have kubectl in the slides here. That's how I say it. This is hotly debated within the Kubernetes community, by the way. So you would be with an excellent company if you disagreed with the way I said it. So again, this is just another view. We have the cluster, we have an API endpoint. You can get to that as a user. It's also being used to manage these worker nodes. All right, so that's baseline. I want to talk a little bit about a couple of new things. Is there an easy way to customize EKS worker nodes? So one of the things that customers have told us over and over again is they really want to bring nodes to EKS for us to manage, but they want to build the nodes their way. So you can do that. There's a lot of easy ways to do that. We also provide a standard Amazon Linux-based node image, a node AMI, that you can use to run if you want the easiest possible way. And people were asking us, hey, we want to take the way you built your AMI, and then we just want to tweak it a bit. So we've been working with HashiCorp Packer, and we have open sourced all of the Packer scripts that we use to build these AMIs. So you can take this. By the way, we would love to have contributions. If you find bugs, if there are features you want, we would love to have contributions on this. So we just announced this recently. We're excited about being able to continue to bring innovation for our customers, not just inside, but also on the outside in the open source community. All right, so that's one very new thing. As you might expect, I've been involved in the Kubernetes Scalability SIG since it formed. Building big clusters, understanding Kubernetes performance is a personal passion, as you might expect as well. Customers care about this quite a bit. And I get asked this question a lot. How many nodes can I have in a cluster? Some of you who have maybe gone and played with EKS will also notice that there is no such thing as a limit to the number of nodes you can put in your cluster. We have talked about doing that by way of providing some guidance to our customers. But we concluded that it was probably not the right thing to do, and I will explain to you why. So this notion of a performance envelope comes straight from aviation, the idea that an aircraft has different performance characteristics depending on its current angle of attack, its current airspeed. In other words, the performance you can get from an aircraft, or in this case from a Kubernetes cluster, depends a lot on the context. What is it you're trying to do? And number of nodes is not the only thing. In fact, it may not even be the main thing. So if you think about building big Kubernetes clusters, you can't just think in terms of number of nodes. You have to think about a whole bunch of things and the trade-offs between those. So these are the main things. By the way, this is a diagram I presented as part of SIG Scalability along with the other co-chair to the Kubernetes community by way of a report from the SIG Scalability group. But it's definitely a key insight. So number of nodes is only one thing. Namespaces. Kubernetes has this really useful feature called namespaces. It's really one of the fundamental ways that you manage permissions and quotas. It kind of looks like a virtual cluster inside the cluster. It can be useful for a great many things. How many namespaces you have has an impact on performance. Scheduling of pods is dependent, potentially, depending on how you're deploying, on figuring out which namespace that pod can go to and what are the restrictions around those namespaces. How frequently are your pods turning over? One of the main things a Kubernetes control plane is doing is trying to figure out where should this container run? I start with a container, I need to run it somewhere on the cluster. If I do that once, don't do it again in a long time, not very much load. If I'm running a highly ephemeral microservices kind of load with a very high turnover, I've seen microservices architectures where customers had a microservice lifetime was the length of a transaction. So pod would come up, perform a transaction, go away. So how much pod churn do you have? That would be container churn more generally. What's your container density? How dense are you trying to run? There's widely varying patterns here. You can run clusters where your nodes are heavily oversubscribed with lots and lots and lots of containers that maybe aren't doing very much work. They're just sitting there waiting to go. So you have a pod density knob. Networking. There's a bunch of different ways to run networking. We have our own CNI. We support VNC directly. We think we have a great solution on the networking front. But depending on what networking approach you've taken, that can affect performance as well. How many secrets? How many special scheduling rules? Anti-affinity is an interesting one, and I think I have a slide to talk about that here in a minute. So what does this mean? This means that if you want to run a really extraordinary number of nodes, you may get to do less of the other things. One of the things here as well, which I don't even mention here, is the assumption is that we're meeting a basic community SLO here. So if you can take a little bit longer to start a pod, then you can stretch the limits here, even beyond what the community normally supports. So you run a large number of nodes, maybe you do less of something else. The opposite is also true. So if you run a large number of nodes and a lot of anti-affinity rules, so anti-affinity is a super interesting and useful placement technique. It says, hey, don't put these two things next to each other, ever. When I say next to each other, on the same node. Don't put them, you can apply those rules in namespaces. You can apply them in a bunch of very creative and interesting ways. Anti-affinity causes the scheduler to have to do multiple loops to figure out where and how it can schedule things because it has multiple things it has to check. So if you use a lot of anti-affinity rules and a large number of nodes, maybe your system can sustain a fewer number of pods per second churned through. Anti-affinity is very expensive. So this led us to the conclusion that the best thing we should do is not place limits, not place hard limits on these things. Try to communicate with our customers about, try to help them a little bit with this kind of performance engineering. Make sure we're talking in the community about this kind of topic. EKS is designed so that 95% of our customers will have a good experience. If you are pushing the limits of one of these things and you are not having a good customer experience as a result, we can help. There are things we can do in the control plane to make these things work better. Reach out through your sales team, open a ticket. We can help you with your really big, really active, heavy secret using clusters. All right, so that's a little bit of a taste. So Alex is going to come up and give us a talk. Alex Strauss, Director of Engineering with Snap. Thanks for joining us. I'm going to turn this over to him, and I'll be back in a bit.
Great.
Thanks.
Thanks, Bob. Can you guys hear me okay? Okay, so just because I was down in the audience, how many people are using Kubernetes today? Show of hands. Okay, that's pretty good. How many of you use Snapchat? Pretty good. Bitmoji? Also, okay, cool. So I'm Alex Strand. I'm a Director of Engineering at Snap. My team works on both the snaps and the chats in Snapchat. So we run the communication group that powers all of the messages that people send every day, whether those are what we call snaps, which are photos and videos, or just regular text messages, emojis, etc. And I think what's interesting to appreciate there is, as technologists, we start with looking at lines on graphs of like messages sent per minute. But if you think about messaging, if you think about all the messages that you've sent this morning, you start with things that are pretty important, like, hey, what are you doing? Where are you going to be later? Are you awake? Do you want me to get you something? How are you? I miss you. And so all of those like human emotions are captured in these messages that we send every day. So for us, it's super important that those messages get delivered. Now, I think for any of you, you would say, yes, like the availability of my system is important. But for us, it's super important because it's like a telephone service. Going this way. OK, so first, quick anecdote. So I joined Snap 2.5 years ago. Before that, I was at Amazon for 9.5 years. And one of the most remarkable things that going from a rather large organization to what at the time was a pretty small organization was this group was able to move really fast with a bunch of open source technologies. So what was really interesting is that companies like Amazon and some other large companies have built up great internal tooling. And a lot of that has started to make its way out into the open source community. And so when we started looking at what I'm about to talk to you about, kind of breaking up our monolith into services, one of the most important things was recognizing that something like Kubernetes was available. And Kubernetes, like, if you're new to it, it's basically magic. Like, this technology, not to make too fine a point of it, like 10 years ago, you just couldn't buy something like this. You'd have to take teams of hundreds of people to build out something to get you even close, if it was even possible at the time. So I think like one thing that's just so remarkable is now, because of open source and a lot of other contributions, that any size organization can use something like Kubernetes on AWS to build massive scale services. Sorry, I got in the wrong direction. OK, so this is Snap's mission. So what I was talking to you earlier about with sending messages, so at Snap, we contribute to human progress by empowering people to express themselves, live in the moment, learn about the world, and have fun together. And so if you think about it, like, not that many companies get to say that they get to be a part of you having fun and exploring the world. Like, fun is actually a pretty big part of our culture. Here's like a very high level of our messaging architecture. So on the left side there is what it looks like when you start with the camera. So if you're not familiar with Snapchat, whenever you open Snapchat, we always start with the camera. So it's your view into the world. And so that's kind of a capture mode if you're going to send a snap. If you're in a chat session, this is kind of what it looks like. You have your friend's Bitmoji presence at the bottom there, so you can kind of see who's participating, and you're sending messages and media back and forth. The messaging architecture itself is kind of a legacy component at this point. It's a giant monolithic backend. So is anyone here like currently dealing with a monolith? Show of hands. Or like a giant unwieldy legacy? OK. So our team has been looking at how do we break this apart into a smaller set of services that are easier to scale and manage, and Kubernetes has a major part to play in that. So if you've heard of the term SOA, service-oriented architecture, to some of you this might be something you already know about. For those that are new, why would you want to do services? Like, why is it bad to have a big monolith? Well, one of the things that you get is this concept of libraries, but kind of at scale. So if you think about it from the perspective of a single application running on a box, you have these reusable components, but really they can only scale to what you can have in a single box. So one benefit of SOA is being able to do that at scale. The second is well-defined APIs. So if you have a strong interface that's hardened between you and your consumers, you get to abstract away everything else behind the scenes. And if you do this well, it means that when you do future upgrades, you want to migrate to different technologies, swapping out your persistence, et cetera, that's something that you can do because you have that service interface where anybody that's managed a large application knows that just swapping out libraries is not an easy thing to do. One of the primary considerations as well is organizing functionality around a certain data domain. So for instance, you might today, if you have a monolith, have the same code deployment handling things like customer data, messages, identity, authentication. You really want to break those things apart because they don't have anything to do with each other. And finally, you get this benefit of modularization. So you break out into one service, and if it turns out that that service is not meeting your needs, you can break it apart again and continue to do that as it makes sense. OK, so why a monolith? Why are monoliths bad? Well, first I'll tell you why monoliths are good. Monoliths are really good if you just have a handful of people that are writing code in a shared code base. It's super easy. You don't have to worry too much. Everybody just codes into the same place. You deploy it. Everything's great. Except for the problem is that it doesn't really scale. It doesn't scale in terms of functionality, and it for sure doesn't scale in terms of people. So could you imagine having hundreds, thousands of people that are developing on the same application backend and just throwing that thing out there for all time? It's not great. So specifically, API locality and separation of concerns. So one thing that's really, really common that can happen with monoliths is you get one part of your application or services in the backend that are really popular where everything else is dormant. So flash sales, DDoS, everybody trying to log in. In our world, it might be if you have a certain account that gets really, really popular and they're getting a bunch of views. So what you don't want to do is have one part of your application be able to brown out effectively the rest of it. So that's the separation of concerns blast radius. Deployment frequency, it turns out that the larger something gets, the longer it takes to build, the longer it takes to deploy. And now your deploy cycles can happen in terms of days instead of hours. Then it could be like once a week, once a month. And once you are not deploying code quickly and have a quick turnaround there, you're in trouble. Ownership, there's this concept of like bit rot. So it's a subtle thing that happens where, again, like the initial group of people, they develop this thing, they thought it was really great, they're passionate, they move on, they go to other teams, change companies, et cetera, and now you have this unowned component. And then over time, like it turns out that the things that are in that bucket that are unowned become larger and larger. They're this kind of like tragedy of the commons. Because it's a monolith, like you don't notice that it's happening until it becomes really painful. And usually what becomes painful is when you're trying to migrate from, say, like one platform to another, and you want to move parts of the monolith over. You can't because nobody actually owns the code, so they're not going to do the work. Operations are really hard to reason about. So for instance, who gets paged in the middle of the night if that unknown thing broke? Who gets paged if it's an unattended side effect of deploying a new feature? Performance, of course, is also really difficult for a lot of the same reasons. So how do you tune a thing that's generalized? It's really, really hard. And finally, security can be a problem because you have everybody contributing to the same thing. And if you're a security engineer, that's probably going to make you break out in cold sweats every night thinking about all the people changing the code. So why services? Why are services so great? So the first is solving a smaller scope in the best way possible. So if you vend a service that's just doing identity, or you're just doing media serving, you can do that really, really well, and you can optimize that service to do that function the best way possible. Again, to earlier being able to separate the data and responsibilities, you don't have these tentacles of reaching into these common objects. So if you think of things like, in most services, and ours certainly, you have a concept of a user, and a user has like friends and media and all these things that hang off of it. Well, in a monolith sense, that user has all of these other services that are kind of like coupled to it and have their tentacles into it. And being able to separate a user out into its own user service makes a lot more sense, and you're not getting into weird consistency states where you're copying data around. Again, with this idea of ownership and organizational changes, if you have, let's say if your company gets large and you decide to have some sort of reorganization or something like that, or a person leaves or team composition changes, with services it's much easier to take a discrete body of work and move it from one organization to the other, where in the monolith land, you're kind of stuck. And finally, like one of the big points is being able to scale tie into usage. So for instance, let's say like World Cup just happened. It was a huge event. And for teams that were impacted by World Cup, so say if it, our team and being able to send expressions of joy or sorrow if your team won or lost, you'd want to be able to scale that service independent of everything else, where in a monolith world, you kind of have to scale everything, and that doesn't make a lot of sense. More importantly, as you think about cost, you really want to be able to optimize the cost of a specific service and show that it has value to your users in the organization, and not just have it be this giant check that you're writing at the end of the month. Okay, so why EKS? This is the big question. So for us, we think that a managed control plane is super valuable. So earlier I said that Kubernetes is magic. I believe that to be true. But it also turns out that a lot of the things that it does that are magical, you don't want to have to manage those things yourselves, right? So we think that EKS is a great solution for Kubernetes workloads on top of AWS because there's an expert team that's thought through all of the challenges. They're going to wake up in the middle of the night if something breaks. They're going to think about how to deploy into new regions, patching versions, upstream compatibility, et cetera. And those are things that you really don't need to worry about for the most part. You should just be able to handle offloading that to EKS. So there's a term that we use internally that's undifferentiated heavy lifting, which is actually really hard to say once you put it on a slide. But what we mean by that is you really want to spend your engineering time focused on innovation, right? Like you don't come to work, and well, you do if you're in an ops job, but if you're writing feature work, you don't come to work to like mess with your Kubernetes configuration. You come to work to deliver customer value. And in my world, that's about making snaps and chats the best experience you possibly can have on Snapchat, and not about all the work that we have to do in order to get that thing working. Like that's just work. And so we think that by leveraging EKS for our AWS Kubernetes workloads, we're able to just take that work, shift it off our plate, and focus on things that are directly valuable to our customers. I also think that it's really efficient from a cost perspective. So as we look at our scaling costs and our consideration, like it just makes sense. Like the amount of time that we would spend for one person to even have to go and debug a Kubernetes issue, we would probably be better off paying the monthly spend every month rather than just paying that one person to go in and debug. So it just makes a lot of sense for us. And finally, our security team is able to sleep better at night because they know that AWS is taking the security story really seriously and that we're not reinventing things from first principles. Okay, so earlier I talked about how we have this big monolithic architecture. I want to talk specifically about how we're breaking this down into a set of services that are going to be running on Kubernetes. There are three specific things that I wanted to call out, and these are choices that we've made that we think are pretty good. This is specific to my team. Happy to talk with any of you afterwards about any opinions on these, but these are kind of three big bets that we have. So the first is Kubernetes, which we're all here for talking about Kubernetes. It just makes sense for service deployments, not having to chase down bad hosts, et cetera. The second is we're writing our microservices in Go. We think that Go is pretty interesting. So far, it's been a good developer efficiency boost. Previously, we were using Java. Nothing wrong with Java if you like Java. But Go's just been faster for us. And so, so far, so good. And then Envoy. Has anybody heard of Envoy here? Show of hands. OK, pretty cool. Envoy is also magic. It's great technology. So we're using Envoy in two places. We use it as a API gateway. It's kind of the front door of our services. And we also use it as a service mesh for our data plane. OK, so zooming into the kind of hello world example. So we're starting out with our service. Now imagine our service is just written in Go. And at this point, our goal is to make it so that the service is really just focused on the local data that it needs, local meaning from a data domain perspective, just the things that it's concerned about, and then also its local business logic. We're going to wrap that in a Kubernetes pod and model it in Kubernetes. And then here's kind of the big picture of how it's going to interact with different pieces. So we have the service, and we have a couple of sidecars. So we have others, but for illustrative example, logging and metrics. So these are other sidecar containers that have nothing to do with the service. So there's another team internally that's focused on things like logging and metrics, and my team doesn't need to worry about that because these sidecars are going to be vended for all the services that run at Snap. Additionally, we're using Envoy for our data plane. So Envoy is doing all of the ingress and egress of traffic coming off of the service. It's also handling auth for us internally. So this is internal service-to-service auth. Super handy. So if you're looking at it from this perspective, at the service layer, like you don't have to worry about all that other junk, right? Like the only thing that you have to worry about is like writing the best service that you possibly can. And then zooming out, so this is an example of we have this API gateway front door, so all traffic goes through that, and then we proxy it out to the individual services per region. We also, in our case, have another non-API gateway, ingress gateway for some use cases around long-lived connections that don't follow request-reply semantics. And then critically, we are writing our own control plane for administering our Envoy instances for things like configuration. So we call that Switchboard. And then zooming out and thinking about the whole world. So this is like from a region perspective. We want to be able to run in as many regions as possible. So Snap has customers all over the world. We want to be able to think about running our services in a multi-region, highly available, high-performance configuration. And with Kubernetes and EKS on AWS, this is pretty easy to do. We're not hand managing all of these clusters. Okay, so I mentioned the API gateway on Envoy. What is an API gateway? So the API gateway is a meta API for our client applications. So when I say client applications, I mean Snapchat on iOS and Android. So this is the kind of like the meta API that's exposed to the public where all of traffic comes in. It's a central point to do authentication externally, so not every service is having to figure out how to do auth. It's a public hardened endpoint, so if you're a security engineer, you're going to think, how do I take this front door surface area and make it as resilient as possible so that there's not individual teams setting up their own external endpoints. And then finally, being able to know, each Envoy knows which region it's in and what it's running on top of. Service mesh. So there's an Envoy sidecar that, as I said earlier, is proxying basically all of the traffic that's coming in and off the box. So what's really handy in Envoy land is if you are, say if you're a messaging service and you say, I need to know about a friend, you can just dispatch the call to say, go and get the friends for this user, and Envoy knows how to route that traffic. You can have standard filters for incoming traffic, so auth, rate limits, being able to throttle, traffic shaping, things like that. all of your outbound HTTP traffic. There's a bunch of interesting, retry, connection pooling, metrics, et cetera. Like, if you get the chance to read the Envoy docs, it's pretty great. It's pretty clear, as a person that's sat through a lot of postmortems, that whoever's written this software has been really thoughtful about what they're doing. We can offload crypto if it's too expensive. We have a live updated configuration that comes from the Switchboard control plane, and so we don't need to do rolling deployments. They get automatically updated. Metrics, et cetera. So this is kind of like the magic piece that's the glue. So if you think about it from the perspective of, I deploy a service, and then I have a collection of services, how do these services talk together? For us, we're using Envoy. And then Switchboard is our internal control plane that we've built to manage all of this. So there are a couple of off-the-shelf control planes for Envoy. They're fine to use. For our use case, we found that there are a couple of choices that we wanted to make ourselves, and so we've invested in our own control plane. One of these is around authentication. We have some auth that we do, so it made a lot of sense. The big picture idea here is, for us, if you think about it, we have been running, so Snap, if you don't know, is 100% cloud native. We don't run any of our own data centers. We're very large scale, and doing it all in cloud is great. It also means that for a lot of engineers that are just joining our company, they haven't done a lot of operations in the past. And so what we want to provide with Switchboard is really a point-and-click control plane where you can set up a new service, deploy to it, route traffic, et cetera, and that it's just easy to use and you don't need to hand manage anything. So that's kind of our recipe pattern for how we're kind of decomposing the messaging services onto, or the messaging monolith onto services, running on top of Kubernetes, using Envoy for the kind of the glue, and Go for our service code. And that is what I have. So thank you, guys. So if you have other questions, by on the side.
Great, thank you very much. That was awesome. All right, I just wanted to make one quick announcement here. So we have this thing we're calling Ecosystem Day. It's coming up here on Thursday at the WeWork Bryant Park. We'll also be online on Twitch. How many of you use Twitch? I've looked at Twitch. I'm tempted to ask if you're if you watch it for AWS reasons or because you follow online gaming. We did the EKS launch on Twitch, and it was awesome. We had so much fun with it that we have started doing all of these events on Twitch. You can see a little screenshot there from our last Ecosystem Day. So that's coming up. Later that day, in the same place, we're also doing an open source event around Kubernetes that we're sponsoring. So there's a great day of activities to be had there. All right, this is housekeeping on submitting session feedback. Please do this if you would. We decided that we wouldn't take live questions in this, but we have a few minutes here, so we're going to end the session, but Alex and I are both going to be happy to hang out here and come talk to us and ask us questions, and that'll be, we'd love to hear your feedback and comments. So thank you very much.